Okay, so you want to then, after you made your hypothesis, you want to actually put it to the test. So you have your hypothesis. Now you want to test. You want to see if your findings come out the way you expect. So you would test your findings through empirical research. And again, that is real-world observations that you would be making. You might manipulate variables in your study, again, do an experiment, or you just might make careful observations. However you do it, there are a number of different research methods to choose from. We'll talk about that in a bit. But you basically design and carry out the research. Do it carefully, you plan it well. You don't just say, oh, let's do a study, and then just go ahead and jump in feet first. You need to plan, you need to design your study carefully so you know exactly what you're going to do, where you would be able to clearly describe your findings and also be able to have someone else be able to follow up on it as well. Okay? So there's a whole bunch of different steps in actually conducting your research, and we'll talk more about that later. But you start with defining your population. What is the population you're dealing with? You might do a study on depression. So your population might be all American adults who have major depression. That could be your population. Now, there are thousands and thousands and thousands of American adults with depression. Perhaps even millions. Well, you're certainly not going to study every single one of them. You have to be able to take a sample from it. So you want to decide how you're going to select your sample from this population of, say, depressed American adults. You want to then, of course, define your variables, and that's where we're getting into operational definitions. Remember, your variables are things that can have more than one value. Things that can be, well, depression could be a variable. Some people may have higher levels of depression than others. But how are you going to measure depression? Remember, different ways of measuring depression. There's the MMPI, which measures depression. There's the Beck Depression Inventory. There are a number of different ways to measure depression. How you operationalize it defines how you're going to measure it. And that's one of the things that scientists have to do. They're dealing with variables, but they need to put it in a language that it clearly expresses how it can be measured. So once you've made your operational definitions, then you would choose the appropriate research method. It could be a naturalistic observation if you wanted to just step back and observe the phenomena in action. It could be an experiment where you're manipulating an independent variable. It could be just a correlational study where you are just looking at the relationships between variables, not manipulating anything, but just more or less making, seeing if there's a connection between two variables. So a number of different research methods you could choose from depending on the types of questions you're asking, the types of variables, the types of operational definitions that you have defined. All of this essentially tells you what is the, maybe what research method might be most appropriate. Really, you realize that different research questions require different research methods. There are some research questions in which naturalistic observation is the most appropriate way to go about it. There are other kinds of research questions in which the only way you can do it is to do an experiment. If you want to establish cause and effect, you need to do an experiment. Okay? So you've come up with the possible research method, and then you want to be able to choose an appropriate setting. Are you going to be doing this in a laboratory? You're going to be doing this in a real-world environment. You got to kind of have to set that up, plan how you're going to do it. So you take a look at, there's a whole lot of things to plan when it comes to conducting research. Okay, so let's start with choosing your participants. You select your participants from a population. You choose what population you are interested in studying. If you are studying depression, you are not interested in the population of iguanas in South America. The iguanas in South America are irrelevant to the study of depression, I think. Unless, of course, there's something about iguanas that might cure depression. If you eat iguanas, it may make you feel better. I don't know. But your population for your sample, if you want to grow your sample from, is you're not going to take a sample of iguanas from the population of iguanas in South America and do a study on depression. So you need to make sure that your population is what is clearly defined, and your sample comes from that population. So the population is your entire group that you're interested in. The sample is a portion of that population that we select for our study. So let's take a look at a practice example here. Think about which of the following is a sample and which of the following is a population. Professional football players, 10 students from Harvard University, albino rats, 100 adults over the age of 65, and 90 preschoolers. Okay. Now, which would you say is probably more a population? And which of these are probably samples? Well, if you think about it, professional football players would probably be considered a population. A whole bunch of professional football players, and maybe you'd like to do some research on football players, maybe on head injuries, for example. You're not necessarily going to do a CAT scan of every single football player in the world, but you might take a sample of football players and give them CAT scans to study perhaps some of the brain effects, some of the things that might be associated with playing football, maybe some of the brain characteristics. So, albino rats would also probably be a population here, and with population, again, there's a huge population of albino rats that different scientists use, but albino rats would certainly be considered a population. And when you want to do your sample, when you want to perhaps teach rats to run through a maze, you are not going to choose every single albino rat in the country. You are going to take a sample of those albino rats and run your experiment on those particular rats. Okay. Well, let's see, 10 students from Harvard, 100 adults over the age of 65, 90 preschoolers. These, you could say, are samples. Okay? 10 students from Harvard University, maybe your population is all students at Harvard University, and your sample might be just 10 students from there. 100 students, 100 adults over the age of 65. There are a whole lot of adults over the age of 65, but maybe you want to do a study and you take a sample of 100 of them. Okay, now when it comes to sampling from a population, there are a number of different ways in which you can do it. And basically, the goal, when you take a sample from a population, is you would like, ideally, that your sample be as similar as possible to the actual population. You want the results you get from your sample to be comparable to the results you would get from your population. So, for example, let's think about this big jar of blue and red marbles. And I asked you to tell me, without counting every single marble, to give me an estimate of the percentage of blue marbles and the percentage of red marbles. So you might look at these and say, kind of looks like maybe 60% red and 40% blue. Maybe you're right, maybe you're wrong. Okay? Well, without counting every single marble, you could just take a handful of marbles, a scoopful, put it in a smaller jar, and then count the marbles just in that smaller jar. Then you would be able to compute the ratio for the smaller jar. And you would probably find that the ratio for the smaller jar is probably similar to the ratio in the bigger jar. Is it exact? Probably not. Could it be completely wrong? You never know. Maybe you got in your handful a whole bunch more red than blue. Who knows? But be that as it may, that is a way of getting a random sample. You're not specifically saying, well, I want to pick these ones because they look prettier to me or anything like that. You're just taking a scoop, red, blue, doesn't matter. And that would be an example of taking a random sample. In a random sample, every member of the population has an equal chance of being selected. So when I scoop those marbles from the jar, maybe I stir it around a bit before I scoop it, then every marble in that jar has an equal chance of getting into my scoop. Okay? If I'm stirring it around, not just taking some marbles off the top, if I'm just taking a scoopful of marbles from the whole thing after stirring it, then every marble should probably have an equal chance of getting onto my scoop and getting into my sample. Now, a biased sample is a sample where not everybody has an equal chance. What if you're looking at depression, and maybe you prefer to study women than men? So maybe you get more women than men in your sample, and you're looking for more women than men. Then you have a bias in your sample. Maybe more women, you're choosing more women than men, even if that is, just because that is your preference. Maybe you prefer people who are tall and not short. You're preferring people who have high intelligence, and you're just ignoring the people who have low intelligence. Well, in that case, you're certainly not taking a random sample of the population of depressed people. You're picking and choosing the types of people you want in your sample. Now, if you're going to do that, what you should need to clearly specify that's what you're doing. But you're certainly not taking a random sample. One of the things you could try to do is try to make a representative sample. The thing about a random sample is that you might do everything right, and you might have everybody have a chance, but you still might get a sample that doesn't really match the true population. Let's go back to the marble example. Let's say I scoop out some marbles. It is possible that the scoop that I have may be mostly red. Maybe it's like 75% red, only 25% blue. Maybe I just happened to scoop in an area of the bottle that had a higher concentration of red marbles. And in that case, my sample, even if it's a random sample, does not really closely match the population. If I'm familiar with the characteristics of a population, I might choose to get a representative sample not using random sampling. Like, let's say I know the population that I'm interested in is 60% female, 40% male. Now, if I take a random sample, I might get 50-50. I might get 60-40. I might get 40-60 in terms of percentages. But what if I wanted to keep it as 60% female, 40% male? Then I would try to get a representative sample based on gender. Maybe I also might want to take a representative sample based on ethnicity. It's another example. So these are things that I might do to try to get a representative sample. Ideally, your random sample would be representative too. In fact, the larger your random sample is, the more likely it would be to be representative of the population. Okay? Let's say your population is 1,000 red and blue marbles. Okay? What if you took 999 of those marbles and you calculated the percentages of red versus blue? I bet you'd get something that is really, really close to the true population, percentage. So there you go. The larger your sample, the closer it is to getting at the true population. As long as it's like a random sample, then that's basically. But even a small sample is still going to be fair. It's not going to be biased.